Question number 11. In triangle ABCD belongs to line segment AB. So first I'll draw the triangle. Here we have triangle ABC. Here we have the triangle. And we call it ABC. ABC. And D belongs to AB, where AD equals 5 centimeters, DB equals 3 centimeters. So AD is greater than BD. So I'll take it here, the point D, such that AD equals 5 centimeters and BD equals 3 centimeters. Also, we have E belongs to AC, such that AE equals 4 and EC equals 6. So here we drop the point E. We have EC equals 6 centimeters and AE equals 4 centimeters. 4 centimeters. Prove that triangle ADE, where is triangle ADE? Here we take a line segment here. ADE is similar to triangle ACB. Prove that triangle ADE is similar to triangle ACB. So we can say that in the two triangles, in triangle ADE and the triangle ACB, we have angle A is common angle, one here, and we make the proportion. Also we have AD over AC equals 5 over 10. Here we have AD equals 5 and the AC equals 10. It is 4 plus 6. And the simplest form equals 1 over 2. And also we have AE over AB equals 4 over 8. We have AE, where is AE? AE equals 4 and AB equals 5 plus 3, which equal 8, and the simplest form is half. This is 2. According to the theorem, from 1 and 2, we can say triangle ADE is similar to triangle ACB. ADE is similar to triangle ACB. This is the first required here. Okay. Second required is to prove that the figure DBCE, this figure, is a cyclic quadrilateral. So we have from similarity that measure of angle ADE, this angle here, equals measure of angle C, and we write it So since it's from similarity, since measure of angle ADE equals measure of angle C, we deduce it from the similarity of the two triangles. Note that measure of angle ADE, this angle, its vertex, equals the measure of angle ACB, okay? And angle ADE is an exterior angle to the figure. So the figure DECB is a cyclic quad. Also, you can say that since measure of angle AED equals the measure of angle B here from the similarity of two triangles, then this figure is a cyclic quadrilateral. Okay. Question number 12. In the opposite figure, the diameter of circle M is 12 centimeters. So we have the diameter, I'll call it ED here. ED, this point is E, and this point is D. And we have ED equals 12 centimeters, and the MC equals CB. MC equals CB. Let us denote it by the symbol X, here X. And the AC equals BC plus 1. And the required here is to find the length of the chord AB. Here we have AC equals BC plus 1, and BC equals X here. So I can write AC equals X plus 1. Okay. There is a relation between these two chords, AB and ED. We have two chords. I know this is the diameter, but the diameter is the biggest chord in the circle. So they are intersect at the point C here. So you can write this relation. EC multiply CD equals AC multiply CB. Again, in the figure, EC multiply CD equals AC multiply CB. And EC consists of two parts, EM, which equal 6 centimeters. So you can substitute EC equals 6 plus X. 6 plus X multiply the length of CD. We know that MD here equals 6 centimeters. So CD equals 6 minus X. It is equal AC. What is the length of AC? AC equals X plus 1. So we write X plus 1 here. Multiply the length of CB. Here we have CB equals X. So we will solve this equation. 6 plus X multiply 6 minus X equals 36 minus X square equals X square plus X. X multiply X, it's X square. 1 multiply X, it is X. And we complete here to solve this equation. We have 2x square plus x minus 36 equals 0. 2x square negative x plus x. Here it will be positive. 2x square plus x minus 36 equals 0. And we will factorize this part here. The left hand side, it will be 2x equals 0. 2x square, it is 2x multiply x. And the negative 36, it is positive 9 multiply negative 4. 9 multiply negative 4, it is negative 36. And 9x minus 8x equals positive x. So 2x plus 9 equals 0. It means x equals negative 9 over 2. And this answer for x is refused, because x is a length of a line segment. Or x minus 4 equals 0. It means x equals 4. Okay, so we have AC. Don't forget that the required here is to find the length of AB. The length of AB here. What is the length of AB? This is the required here. Okay, AB equals AC plus BC, right? AB, all the length of AB equals AC plus BC. It is equal AC. Here AC equals x plus 1. So, and we have x equals 4. So you can substitute AC by the number 5. It is 4 plus 1 plus the length of BC. BC, it is x here, and we deduce that x equals 4. So the result equals 9 centimeters. And we choose letter D here. Okay. Next question. Question number 13. The degree measure of the angle whose measure is 7 pi over 6 equals 105, 210, 420, or 400 or 840. Here we have a relation between the degree measure and the radian measure. We have theta in radian, it is a rule, over pi equals theta in degrees over 180 degrees. So we substitute here. Theta equals 7 pi over 6 divide pi equals theta in degrees. The required there is to find the degree measure, okay, over 180. We can divide here 7 pi over 6 divide pi equals 7 over 6. So the right hand side equals theta degrees over 180, and then theta degrees equals 180 multiply 7 all over 6. Here divide 6 equals 1, divide 6 equals 30, and the result equals 30 multiply 7, which equals 210 degrees. And we choose letter B. Question number 14. Investigate the sign of the function f where f of x equals x squared plus 3x minus 10 and illustrate it on a number line. Then determine the solution set of the inequality x squared plus 3x less than or equal 10. So first put x squared plus 3x minus 10 equals 0. Okay, the function here x squared plus 3x minus 10. So we put x squared plus 3x minus 10 equals 0, and we factorize it. It will be here x squared, it is x multiply x, and 10 equals 2 multiply 5 here, okay, or 1 multiply 10, right? But we want the two numbers, the difference between them equals 3. So we'll choose 2 and 5, and it will be positive 5 multiply negative 2. Okay, so x plus 5 multiply x minus 2 equals 0. It means x plus 5 equals 0, or x minus 2 equals 0, and we deduce x equals negative 5 or x equals 2, and we draw the number line here, and we write f of x and x and the zeros of the function. So we write x and the f of x here. We have the two zeros, the two roots, negative 5 and 2. So when x equals negative 5, then f of x equals 0. When x equals 2, also f of x equals 0. And we check the sign in these three intervals. When you take a number lies between negative 5 and 2 like 0, so f of 0 equals 0 plus 0 minus 10. So here we have a negative sign. When you choose another number like 3, it is greater than 2. F of 3, it will be positive here, and here also is positive. Okay, so what you can deduce from this number line, f of x is positive, greater than 0, it means positive, and the two intervals from negative infinity to negative 5, and from 2 open, of course, to infinity. Also, f of x is less than 0 in the open interval from negative 5 to 2. F of x equals 0 when x equals negative 5 and when x equals 2. Now we have x squared plus 3x less than or equal 10. So x squared plus 3x minus 10 is less than or equal 0. So the solution set of the inequality here equals a closed interval from -5 to 2. ABC is a right angled triangle at A. So we'll draw a right angled triangle. AD perpendicular to BC. So we draw AD, start from A, perpendicular to BC. Here is this angle equals 90 degrees. Where D belongs to BC. D belongs to line segment BC. So AB square equals AB square equals its projection BD multiply the length of the hypotenuse BC. Okay, so we have BD multiply BC and the answer in letter A. Question number 16. If the 2 points x1 cosine x1 and x2 cosine x2 lie on the curve of the function f of x, equals cosine x, where x in radian measure, then the greatest value of the expression cosine x1 minus cosine x2 equals space equals 1 equals 2 equals 0 equals 180. We know that cosine x, cosine any angle x, it's belong to the interval -1 and 1. The smallest value is -1 and the greatest value to cosine x is 1. So the greatest value to cosine x1 minus cosine x2 equals here putting cosine x1 equals 1 minus cosine x2. To get the greatest value, put cosine x2 equals -1, and this is equal 1 plus 1 equals 2. So the greatest value equals 2 here, and the answer will be letter B. Question 17. Here prove that dy bisects angle ADC. To find the measure of angle XDY. So let us concentrate in this figure here. So prove that dy, where is dy? Here, dy, I'll draw it in a different color. Here, dy bisects angle ADC, this angle. Okay, so to prove that dy bisects angle ADC, we must find the relation between DC and DA, also AY and CY. Okay, here we have dx bisects angle ADB. So we say in triangle ADB, or is triangle ADB, we have dx bisects angle ADB. Okay, we have dx, dx bisects angle ADB. It is given. So we have as a relation ax over xb equals AD over dB. Again, we have ax over xb. Start again from A equals AD over dB here. Okay, and we call this relation 1. And in triangle ABC, triangle ABC, we have according to the given xy is parallel to BC. Here xy, it is given, right? xy bisect parallel to BC. Okay, then we deduce that AY over YC equals AX over XB. Again, we have XY is parallel to BC. So you can say that AX over XB equals AY over YC, or AY over YC equals AX over XB. Now we have AX over XB here equals also here we have AX over XB. So you can deduce from 1 and 2. We call this 2. From 1 and 2, we have AD over DB equals AY over YC. AD over DB equals AY over YC, but since D is the midpoint of CB, then you can say that DC equals DB. So we will use this since CB equals DB. You can substitute DB by CD, and we write AD over, instead of DB, I write CD. Equals AY over YC. So according to the theorem, we can deduce that dy, ray dy, is the interior bisector at D. Bisects angle ADC. This is the first required. Second required here, find measure of angle XDY. XDY. So we have a relation here. We have dy is the bisector of angle ADC. So measure of angle ADY equals the measure of angle CDY here. So let us number these angles here. Here we have angle 1, 2, 3, and 4. And we write measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 equals 180 degrees, because angle CDB is a straight angle. Its measure equals 180 degrees. Here we have angle 2 plus angle 3 equals the measure of angle 1 plus measure of angle 4, because 2 equal 1 and 3 equals 4. So measure of angle 2 here plus measure of angle 3 equals the measure of angle 1 plus measure of angle 4. So you can write 2 multiply measure of angle 2 plus measure of angle 3 equals 180. Dividing both sides by 2, we get measure of angle 2 plus measure of angle 3 equals 90 degrees. And the measure of angle 2 plus measure of angle 3 gives us measure of angle XDY. It is equal 90 degrees. And this is the second required. Next question. Here we have in the opposite figure, AC touches the circle M at C. Here and we'll consider it in this figure here. And the MC equals 6 centimeters. MC equals 6 centimeters. And the PM of A equals 64. Then AB equals space centimeters. We have BM of A equals 64. It is given. And also PM of A equals AC power 2. So AC power 2 equals 64. And then AC equals the square root of 64, which equal 8 centimeters. 8 centimeters. And then concentrate in this triangle ACM. We have AC is a tangent and the MC is a radius. So measure of angle ACM equals 90 degrees. And applying Pythagoras theorem, we get AM equals square root of 6 power 2 plus 8 power 2, which equal 10. So we have AM equals 10, and we have AB. So AB equals AM minus BM. What is the length of AM? It is 10 centimeters. So we write 10 centimeters minus BM, which equals 6. And the difference equals 4 centimeters. And we choose letter B also. Letter B. Question number 19. The opposite figure represents the curve y equals ax squared plus bx plus c. Which of the following is true? Here, this curve is opened downwards. So the coefficient of x squared, it is a. A must be less than 0. Okay? And it is intersects passing through the point 0 and C. Here you can put x equals 0. In this point, x coordinate equals 0. You have here y equals ax squared. So putting x equals 0, you will get a multiply 0 power 2 plus b multiply 0 plus c. It is equal 0 plus, here is 0, b multiply 0 equals 0 plus c. So y equals c. This point is 0 and 0. It is the origin here, but this point is 0 and c. Okay, so c is positive. It is greater than 0, which means it is positive value. So we'll choose this. A is less than 0 and C is greater than 0. And this is in letter C. Next question, question number 20. We have cosine x equals 3 over 5. And the x is less than 360, greater than 270. So it lies on the fourth quadrant here. You know that here all the trigonometric functions are positive, and the sine function is positive. Sine any angle theta is positive. Here, of course, sine and its reciprocal, cosec theta, and here is tan theta and cotan are positive. In the fourth quadrant, you have cosine and its reciprocal, its sec, are positive. This angle here, x, lies between 360 and 270, so it lies in the fourth quadrant. So we write cosine x equals 3 over 5. So it is belongs to fourth quadrant. and I'll draw it again here for in another figure like this. So the angle, the terminal side will be here, and you complete the triangle. So we have here angle X. Again, back to this ratio. We have cosine X equal to 3 over 5. 3 over 5. 5, it is the length of the hypotenuse. It is always positive. And the 3 here lies in the positive direction of x-axis. So it is positive. And the cosine equals adjacent over hypotenuse, 3 over 5. And this angle equals 90 degrees. You can deduce that the length of the opposite to angle X here equals square root. Actually, it's positive or negative, right? Positive or negative square root of 5 power 2 minus 3 power 2, which equal positive or negative 4. Okay, but here y coordinate is negative, so we choose that the opposite side y coordinate equals negative 4. Okay, it is equal negative 4. Back to the required. The required here is to find the sine 180 minus x. Okay, now we have cosine x equals 3 over 5, right? And sine x from this triangle equals negative 4. It is y over 5, negative 4, divide 5, okay? And tan x equals opposite, negative 4, divide hypotenuse, divide adjacent equals 3, okay? And I'll use this ratios here, 1, 2, 3. I'll use this in to find the answer of the required. So we have here, I write it in this line here. Okay, we have sine, it is the required sine 180 minus x plus tan 90 minus x plus tan 270 minus x. Okay, and we complete. We have sine 180 minus x equals sine x. Lies in the second quadrant, plus tan 90 minus x. It is in the first quadrant. It will be cotan x. Here, tan 270 minus x. This angle, its terminal side lies on the third quadrant, so the sign will be positive. It's tan, positive tan, and it will be cotan because we have here 270 convert tan to cotan, so we have tan 270 minus x equals cotan x. Okay, so we have sine x plus 2 cotan cotan x. Okay, equals, what is the value of sine x? Sine x equals negative 4 over 5 plus 2 multiply cotan x. We have tan x equals negative 4 over 3, so cotan equals negative 3 over 4. It is the reciprocal, and all of this equals negative 4 over 5 plus negative 6 over 4. And we'll use calculator. Negative 4 over 5 plus negative 6 over 4, and the result equals negative 23 over 10. Negative 23 over 10. So this is final answer here. Question number 21. In the opposite figure, if M is the point of concurrence of the medians. Here we have M. It is the point of intersection of all medians. Okay. Again, here what is the meaning of concurrence? The point M is the point of concurrence of the medians. So M divides A. I'll call this E. AE by the ratio 1 to 2 from the base. Okay, and we have of triangle ABC, and we have DM is parallel to BC. Then the required here is to find the DM over BC. DM over BC. From the given, since MD is parallel to EB, so triangle AMD is similar to triangle AEB. Then the corresponding sides are proportional. So AM over AE equals MD over EB. Again, back to the figure, AM here over AE equals MD over EB. What's the ratio between AM and AE? If AM equals 2, then AE equals 3. So we have this ratio here. Instead of AM over AE, I will write 2 over 3. Okay, it is equal MD over EB. Okay, but EB, it is half BC, right? Because AE is a median from the given. So E is the midpoint of CB. So you can say that CE equals EB, and also EB half CB. So we can substitute here. First we write 2 over 3 equals MD over EB, and the EB equals half BC. So the required here is to find the DM over BC. We have MD over BC. Okay, so we write here it is the solution. MD, it is dm, MD over BC equals 2 multiply half over 3, which equal 1 over 3, and we will choose letter B.